Hello to everyone. Synergetics Plates. I'm quoting Kirby from his last post to JB. Check this color poster anytime you get confused. The red tetrahedron is unit and it's said to have unit edge. The top row tetrahedron, in contrast, is said to have edge too. Clearly this top row tetrahedron is the 2-frequency tetrahedron with the volume 4 octahedron yellow inside. This poster gives the elementary school version used in say baton, right down to the A and B modules. Okay, so now we have a totally new version of the simple synergetics econ. So let's start with row 3. Regular tet edge equals 1. It's not 2 as I said, it's 1 now. We still have the same sphere, it's just a diameter, it's 1, and the radius must be then 0.5. Divide to 4, then stack those to the rhombic, to the octahedron. So let's say, so we have this tetrahedron, same tetrahedron, we divide it into 4, like that, well 2 and here is 2. So we divide that into 4 and we're going to place it on the octahedron just like it says. The last row in blue, last picture of third row in blue, and we have our rhombic dodecahedron. Edge of that rhombic dodeca is now edge 1 as Kirby says, but it's still the long diagonal of there. So we are on the same scheme. Alright. Now let's do row 2. We have a half octahedron, it's painted yellow. We divide it into 4. So we have 1. Okay, what is that 1? And 2. Now these two, it's same thing. So we're going to place that, as it says on the plate, onto this tetrahedron. And we have a cube. And we see the cube, it's a red tetrahedron. Now the cube is edge 24 blocks, cube has 72 blocks, but now the diagonal is 1 according to the Kirby, which is a problem again. Now let's go to row 1. Tet edge equals 2, so now we have a tetrahedron and its edge equals 2. So we have our octahedron, red tetrahedron here. Here is other tetrahedron. I didn't paint it red, but you guys see red, and then this should be red also. That's the other tetrahedron. And we have the same spheres. These are the isotropic vector matrix sphere. Now we remember the radius is 0.5, so we have 0.5, 0.5, 0.5, and 0.5. So 4 times 0.5 is 2. So the diagonal, the edge of this tetrahedron is 2 now. But now the cube diagonal is 2, but it contains 3 spheres on edge, which again is a problem with unity, because unity equals 2 or 2 radii. Well, this is a problem again. Oh, I know we can employ philosophy and metaphors. I'm sure with that everything will fall into place as usual. So yes, synergetic is very simple, but now again a new problem occurs. If this is the new truth, then the isotropic vector matrix spheres, which are this one, the stacking spheres, are after all the same spheres enclosed by the rhombic dodecahedron. This is the rhombic dodecahedron, and this rhombic dodecahedron, folks, is same as in my scheme. That's our anchoring point. We have mites, just like synergetics that this is a rhombic dodecahedron, this is a 2-frequency cube. Synergetics has the 1-frequency cube. Now the diagonal of that cube is 1. And here is the rhombic dodecahedron, but the problem is that this is your isotropic vector matrix spheres, as I just demonstrated. That's what you're claiming. But this sphere is also enclosed by the rhombic dodecahedron. as I demonstrated previously, again this is a huge problem, an impossible version of reality, because in your previous post you also said that you also have spheres even smaller, you call them reduced by 0.5, which now means these new spheres have to be not 0.5 but 0.25. Radius have to be 0.25. This is where the 2.5 synergetics volume cube octahedra exists. Has 20 of these tetrahedrons, so now your sphere ended up to be 5, so now we have to go half of the radius. So it will be 0.25. This is your cube octahedron, and it contains 60 of these A modules. So it's obvious now we have 3 different kinds of spheres. Let's not forget the cube octahedron of synergetics cube. I painted it red so we don't get confused. This is a 24 block tetrahedron. There is 480 A modules of this. This is a 1 frequency tetrahedron. Now this is edge 1. So we have 3 different kinds of sphere, and here is the basketball sphere enclosing this. It's doing the same thing. I've done it in here with the stacked isotropic vector matrix spheres. So people, you guys can see the relative volumes of these solids. Well, I'm trying in which every way. Synergetics is very cool, easy, clear, comprehensive, simply brilliant. Any Yahoo just can wake up and ask, what is the isotropic vector matrix sphere? And then he writes a long essay on a subject. This guy is now validating my work. He does not agree with me. He's not agreeing with Kirby. He is the version of himself. So Synergetics also employs the mathematical democracy. What a wonderful idea. Anyone can explain to himself. It's basically like explaining an abstract art. It's anything you wanted it to be. And whatever the conclusion is, it is good for the giving moment. This is just too brilliant. So see you all later.